Students, we are given this question. If z is equal to x positive iy and the argument of z negative 1 divided by z positive 1 is equal to pi over 2, we are expected to show that x squared positive y squared is equal to 1. So foremost, what we are going to do is we are going to be first considering z negative 1 divided by z positive 1. Now students, we are given that z is equal to x positive iy. So substitute x positive iy for z, and also for the denominator it's going to be x positive iy. Now there is a positive one there, so make sure to place that, and there is a negative one there, make sure to place that for the numerator. I can rewrite this as by clubbing the real part together. So this is going to be x negative 1 positive I times y divided by x positive 1 positive I times y. So this is the quantity that I've got. Now what I'm going to do, I'm going to be multiplying the quantities by the conjugate of the denominator. So that's going to be x positive 1 negative iy divided by x positive 1 negative iy. Okay. Now this is equal to, now actually you can see here I have a quantity x minus 1. So we need to start by multiplying x minus 1 with x positive 1. So we can use the formula a negative b multiplied with a positive b would give us a squared negative b squared. Okay, so that is a keen observation we have to make here. Now followed by x minus 1 multiplied with negative iy. So it's going to be negative I times y multiplied with x negative 1, followed by positive iy multiplied with x positive 1, and then positive times negative would give me negative. I times I was going to be I squared. Y times y is going to be y squared. So this has to be divided by the denominator. Now this is actually a minus b multiplied with a plus b. But the only difference here is we have got the presence of a I there. So that would mean the outcome is going to be a squared positive b squared. So have that in mind. So this is going to be x positive 1 raised to the power 2 positive y squared. So much so for the denominator. Now let us simplify the numerator. Now the numerator, the first term is going to give us x squared negative 1. Now we have got iy multiplied with x. So let us see what we are going to get there. So that's going to be negative I times yx, negative times negative is positive I times y, positive I times yx, positive iy. This is I squared, that's negative 1, and you have a negative 1 outside, so that's going to be positive. So you are going to get y squared divided by x positive 1 raised to the power 2 positive y squared. Now negative iy can be cancelled with positive iy. Now iy and iy can be added, giving me 2iy. So I got a quantity which is equal to x squared positive y squared positive 2 times iy divided by the denominator, which is x positive 1 raised to the power 2 positive y squared. So this is nothing but z negative 1 divided by z positive 1. So the problem is not yet complete, so let's go to the next page. So we got z negative 1 divided by z positive 1 to be as x squared positive y squared negative 1 positive I times 2y divided by x positive 1 raised to the power 2 positive y squared. Now I'm going to write this as real part and imaginary part. So that's going to be x squared positive y squared negative 1 divided by the denominator x positive 1 raised to the power 2 positive y squared followed by positive I times 2y divided by x positive 1 raised to the power 2 positive y squared. So this is my real part followed by the imaginary part. Now we are given that the argument of z negative 1 divided by z positive 1 is equal to pi over 2. So the argument of this quantity is going to be, now you know that the argument formula, right? The argument of a complex number is tan inverse of y divided by x. Okay, so if you were to find the argument of z, okay, therefore the argument of z negative 1 divided by z positive 1 is going to be equal to tan inverse of y term is going to be 2 times y divided by x positive 1 raised to the power 2 positive y squared. This is for my y term, divided by my x term is going to be this, which is x squared positive y squared negative 1 divided by x positive 1 raised to the power 2 positive y squared. Okay, so we can stretch this quantity. Now clearly the denominator can be cancelled, so that would leave us tan inverse of 2y divided by x squared positive y squared negative 1. So this is what we are getting. On the left side it is argument of z negative 1 divided by z positive 1, but we are given that the argument of z negative 1 divided by z positive 1 is pi over 2. So this is 1, let it be, this is 2. So from 1 and 2 we get, so what do we get? We got to equate these things. So we have got tan inverse of 2y divided by x squared positive y squared negative 1 is equal to pi over 2. Now move this tan inverse to the right. So that would mean we would now have 2y divided by x squared positive y squared negative 1 is equal to tan pi over 2. Now what is tan pi over 2? Tan pi over 2 is tan 90, right? Now what is tan 90? Tan 90 is sine 90 by cos 90. Sine 90 is 1, cos 90 is 0. See, the meaning of this is nothing but this implies tan pi over 2 is equal to 2y divided by x squared positive y squared negative 1. Now this can only be true if x squared positive y squared negative 1 is equal to 0, right? That's the only way, because we know tan 90, right? I've demonstrated here what is tan 90 exactly gives us. Now, so that is only possible if x squared positive y squared minus 1 is equal to 0. Now from here we can clearly conclude, okay, x squared positive y squared is equal to 1. If you were to move one which has a negative sign to the other part of the equal to sign, you get x squared positive y squared is equal to 1, which is the required result. Okay, so that completes the